the space. He also led the design and development of more than 50 electro-optical imaging sensors, which is the core of any of the satellite missions. And since starting from this Bhaskara, this one 1979. Welcome. So, see, also he has been president of the Aeronautical Society of India. He's a fellow of the Indian National Academy of Engineering, National Academy of Sciences India, Indian Society of Remote Sensing, and so on. So he has also been, elected member of various international academy of, academies, and he has also been conferred with honoris causa as well as DSc by 18 Indian academic institutions. So with this very small, brief introduction, I request Sri Kiran Kumar ji to please go ahead with this presentation. Thank you so much.
Good afternoon to all of you. Yeah, I can use it from here itself. It will connect it. Okay, good afternoon to all of you. At the outset, I would like to thank NIOT and the organizers of this WOSC to give me an opportunity to share with you some of the activities on space-based observation for developing blue economy, contributing to UN's Ocean Decade initiatives. Okay. Yeah, thank you. So before I start, I just want to give a small story which actually showcases how India made use of space technology for addressing one of the very key problems in the country. Probably you're all very familiar way back in 57 when humanity got in a way a new disruptive technology of being able to go beyond planet Earth. Russians put their first Sputnik into orbit. At that time, we had a great visionary scientist in our country, Dr. Vikram Sarabhai, who was looking at how this ability of going beyond planet Earth can be used to solve the problems we face in a developing country. We were just 10 years into independence, and at that time, how can we make use of this great technological leap that is there? So, what he did in a way was convincing his friends across the globe, showcasing to them that we have a unique place in Tumba, which is a geomagnetic equator. And if you conduct upper atmospheric research there, it will benefit the scientific community. And with that in mind, sounding rockets were brought into this place. And in the church, what you see here is the place where the first sounding rockets got assembled. And just last year, we completed 60 years of sounding rocket activity in India, and how it made a huge difference. See, when the first rockets had to be launched in that place, Dr. Sarabhai had to convince the fishermen in that region that they need to vacate the place where these sounding rockets are going to be launched for India to make a progress. And for this, he had to actually use the services of the bishop to convince the fishermen that you let this opportunity for us, one day the country will benefit. So, as though what he had promised became a reality, 1999 onwards, India was able to provide through Indian National Center for Ocean Information Systems in Hyderabad, by looking at the color of the ocean in many different wavelengths and also the sea surface temperature, identifying the chlorophyll, and through that food chain of the fish, identify where in the ocean you can capture the fish. And this information was started being provided to the fishermen along the 7,500 kilometer long coastline what was there. And in fact, the earlier studies by MOES also shows this one act of providing the information to the fishermen to the in the country saves between 10 to 15,000 crores a year, because the fisherman now is in a way assured of the fish catch, and the amount of fuel he spends in petrol and diesel is so much reduced that the kind of saving that happens. And the country also moved ahead, and today we have a series of ocean sat observation. But beyond that, our own navigation satellite, which is capable of providing you location information. A small battery operated gadget is fitted into the boat of the fisherman, and this gadget locates itself in terms of latitude, longitude, like your mobile, and using our Navic satellites, and also a messaging system which is available in this passes on the latitude and longitude of the prospective fishing zone. And now a mobile in the hands of the fisherman, the mobile itself does not have any connectivity to the terrestrial tower, because you can imagine once you go a few kilometers into the ocean, no terrestrial tower can reach the mobile. But then the mobile communicates with the gadget fitted in the boat through Bluetooth or Wi-Fi, and then the app in the mobile converts the information of both location and prospective fishing zone as a video compass and points to the fisherman where he has to go for fishing. Not only that, he is also being alerted in his mother tongue if the weather conditions are going to be unfavorable in the coming days, or even if sea state roughness is going to be unbearable. Or many times you have read our neighboring countries capture the fishermen when they wade into their waters, even alerting them of the reach going beyond their international water boundaries and in their mother tongue. So you can see here an example of the most advanced technology of satellite launch through launch vehicles, providing specific information to a person who does not know reading or writing, but making use of the specific information for his livelihood. This, in fact, is an extremely important development which has happened using the space technology based, both in terms of remote sensing and both in terms of communication and navigation capabilities. So this is a story which I keep telling, because unless we tell more and more today, what has happened is these gadgets, our New Space India Limited has given a contract to produce more than 1 lakh such units, and state governments are going to provide these gadgets to the fishermen. So that is the way it is progressing. Now we have a large number of satellites being put for various applications, both in terms of remote sensing, optical, infrared, microwave, all these, and also from low Earth orbiting platforms and geostationary platforms to provide specific inputs to the various activities of societal applications. So this shows recently we had Insat 3DS, which is launched and it has already reached its geostationary location. And in the coming few weeks, it will be put into operation. So it provides a 6-channel imager and a 19-channel sounder. And this adds to the two satellites which are already operating, Insat 3D and 3DS. Similarly, this year you will also see, I'll touch upon it a little later, NASA ISRO Synthetic Aperture Radar mission, which is one of the most advanced technology sweeps are based system, which will provide something with every 12 days information about the entire global surface. You will see some details later. And we also work with others, whether it is altimeter from Saral, working with the French team, and also many geostationary platform instruments. Now, today, if you are looking at blue economy pillars under sectoral GDP contributions in the global scenario, you can see the coastal tourism, oil and gas, and then marine fisheries, ports, and a host of things. All of them require not only information generation, but also modeling and various activities. Renewable energy for sustainable marine energy can play a very vital role. And then fisheries, we have already seen that India is making significant use of the capabilities that is there. And what is remains to be done is also much more. And then maritime transport, and then climate change. Oceans are very important, both for carbon sink, blue carbon, and help mitigate the climate changes. Then, if you look at Indian perspective, nearly 15% of the total population live in the coastal regions in India, and blue economy and can enable unprecedented opportunity to meet its national socio-economic objectives, as well as strengthen the connectivity with neighbors. It also provides a means of livelihood generation, achieving energy security, building ecological resilience, and improving health and living standards. And towards this, a large number of activities in the country, whether it is the Deep Ocean Mission or Samudra Program, then India-Norway Task Force set up for sustainable development, or Ocean Smart Scheme, integrated coastal zone management, National Fisheries Policy and Sagarmala project. They are all activities which are enabling the blue economy growth in the country. Now, if you look at in terms of the activities, Deep Ocean Mission is part of the Ministry of Earth Sciences activity, which aims at development of technology for deep sea mining and marine submersibles, ocean climate change advisory service, then exploration and conservation of deep sea biodiversity. And similarly, if you look at Sagarmala project of Government of India, its development of all the major ports, infrastructure, what is required, and the blue economy major pillars in terms of satellite perspective. If you see, you have the samudra, then the fishery, tourism, and the ocean economy. Host of them are there. Then today, if you see, MOS and DOS work hand in hand on many activities. The left top shows the kind of the ship routes that are there and the kind of density that is there. And based on the satellite observations, one can get synoptic and repetitive coverage of information. And then it enables, in contrast to sparse data available from in situ observation, satellites can provide a global coverage. And then, of course, there are limitations in terms of what parameters can be measured, because much of it is what can emanate from the surface, and through that and through modeling try to get into the deeper into the ocean. And then if you look at surface observations from ship and buoys, generally is not so much sufficient for many activities. But then you can also see that ship traveling at speed of 10 knots require almost 10 years to cover the same area, which a satellite can do in a couple of minutes. But then whether all the information that you want is available today or not is a question. But then technology, as it keeps growing, we need to find ways and means by which these things can be done in future. Now, some of the collaborative efforts that are going on, if you look at, one of the key important aspect of space-based observation will be how do you validate all the data that you generate so that it can be effectively used in the various models. And then here, Space Application Center, along with in collaboration with NIOT and then NIO and NPL, have established a calibration facility in Kavarati, and it caters to many of the missions of ISRO, whether it is the OceanSat or Megatropics or Saral or INSAT 3D series, etc. And then continuously effort is on to validate the information and provide. Recently, for example, the OceanSat 3, which is again an improvement over the earlier versions. Instead of 8 channels, now it has a 13 channel version. And also it is designed for global coverage. And today you can get actually global coverage information from OceanSat 3. And then it carries a scatterometer, which also provides ocean wind information. And we share this information not only within the country, but also for the weather community. All the weather forecasting models get this data within 180 minutes of acquisition, and a host of these activities are in progress. Then if you see, again, in terms of validating with the Kavarati, and not only our own calibration site, but also global calibration sites which are there, using that the information generated from space-based observation are validated using in situ observation, and this helps in improving the models and then model prediction activities. And then this, of course, shows the kind of validation cruises that are done using along with NIOT for parameters like chlorophyll, aerosol optical depth, ozone, and then pigments, nutrients, and many such parameters. Then, of course, today you're also in a position to make use of the data coming from this generate. Unlike in the earlier period, now using OceanSat, you can get global coverage on a regular basis. And this information is also available through Bhuvan and Bhunidhi portals, and one can access this information in a significant way. Then other aspects of this, if you see, using our synthetic aperture radar, the ocean internal waves can be actually studied, and then SAR can detect ocean internal waves, which can be confirmed through the mooring observation, and also a lot of work still needs to be done on both in terms of information on internal waves, and this is also a very important aspect of many naval applications that are there. Then if you see coastal inundation due to storm surge, simulation, validation, and operationalization. This again a very important aspect, because all the cyclones and super cyclones can cause significant storm surge, and then the impact of that, if you have to study, not only you require model and technique development, but also validating that, and then continuously improving our ability. While lot of work has happened, but then lot more needs to be done, because even the digital elevation model what gets used needs to be generated with higher spatial resolutions, and then also in terms of improving the model to give prediction for storm surge and also flooding due to these waves in the coastal regions become important, and lot of work is going on in this, and lot more needs to be done further. Similarly, if you look at for wave forecasting system, here again activities like model techniques have been developed using altimeter and Argo data assimilation for high resolution model. And this is also an activity which has been done, and currently at INCOIS, this is becoming effectively operationally usable. And current technology is available with INCOIS. And the current limitation is, of course, there are many unresolved processes which have to be still actually not only comprehended but also incorporated in the model, so that in the coming days you can make a better prediction and better results can be obtained on this. So this is again another wave forecasting system activity is very important. Then similarly, if you look at multi-temp sensor approach for food security, like what I pointed out to you about the fishing, prospective fishing information, today the sensors, not only optical, infrared, sea surface temperature, or microwave sensors, which are providing wind vector information of the ocean, and all of them put into the model, so that you can even predict few days later where the fish schools or prospective fishing zone can propagate. And current effort is to overcome the current limitation of coming closer and closer to the coast, and also improving the both in terms of the resolution and the accuracy of these predictions, and ultra high resolution satellite chlorophyll estimation. And as systems are getting generated and technology is moving towards higher and higher resolution system, these activities will become much more effective in the coming days and decades. Then oil spill is another activity which can be actually picked up from based on the space-based remote sensing observation. And again, with significant amount of validation, this can become really operational and provide inputs both in terms of oil spill activity. And here again, the current limitations have to be overcome. This is where the research and the ability to improve on what we are doing currently has to be improved. Then harnessing the offshore, the alternate energy sources and renewable energy sources, when one is looking at not only mapping and also generating large amount of database over many decades, and using that, identifying what are the regions or what are the places where it is important to establish such wind energy harvesting systems becomes possible. And then here again, continuously effort of improving our ability to not only make observation but also create. See, today, for example, you are familiar, solar harvesting, the places you take a latitude, longitude of any given location, it is possible to tell what is the percentage of sunlight that is going to be available there. In a similar manner, lot of activities with respect to offshore wind energy, monitoring, and then creating databases from space is a possibility. Then if you look at shoreline change analysis and coastal zone mapping, and in fact, India, one of the big activities that happened based on the remote sensing was even the coastal zone mapping activities, and also coastal zone regulation activities, which required significant amount of inputs from space-based observation. This is continuing. And again, here again, what needs to be done is improvement over the existing processes with both the data acquisition, modeling, and then validating. All of them becomes very important. And change detection and also predicting the change due to climate changes also become very important, so that you can be forewarned and also be prepared for policy changes that would be needed. Then climate change impacts on coastal sea level rise. This again a very important aspect. Coastal vulnerability due to storms in the backdrop of sea level rise becomes important. And here again, you see the IPCC satellite observation, numerical ocean models, and statistical methods all go into this activity. And here again, there is a significant amount of research opportunity that is available. Then if you see marine pollution, again, plastics is a big problem, and huge quantity of plastics which are produced, and significant amount of them finally find their way into the ocean. And both monitoring it from space-based and even drone-based observations are currently in progress. And then here again, not only making observation but also how to bring this specific information to the concerned, and how to make sure that we are able to deal with these kinds of pollution activities for sustainable ocean activities becomes very necessary. Then if you look at again in terms of application areas, these are the primary areas you can say. One is a tropical cyclone itself, storm surge, swell, precipitation, inundation. In all these place areas, aid in risk reduction, disaster risk reduction, then help in developing early warning system and facilitating adaptation measures. All of this are an essential component of sustainable ocean activities. Then if you see in terms of blue economy, another important aspect is satellite-based marine application for sustainable development areas. This is an international cooperative initiative under Committee on Earth Observation with a focus on coastal region. And the focus is not only understanding the impacts of sea and on coastal water biophysical processes, parametric parameters of interest from satellite for both from sea to land and land to sea. They are important. Various parameters of physical oceanographic forcing, sea level, waves, winds, tides, then near shore bathymetry. So all of these parameters, if they have to be monitored and developed, observed, and then similarly from land to sea, what is expected, of course, is CEOS is tackling the coastal Earth observation frontier and supporting the decadal outcome of a predictable ocean with coastal observation, application, services, and tools. So this is where a lot of international collaboration and cooperation in the area of ocean is happening, so that the not only planet Earth becomes a more sustainable, but ocean itself becomes a sustainable place and does not get overutilized or over exploited. Then here again, opportunities, if you see in the near future, there are many new observation systems which are going to come up, both in terms of Ka band synthetic aperture radar interferometry, and also making use of the dynamic topography. And there are many parameters which are going to be extractable from these systems, and this captures subscale and mesoscale features. And SST, recently we had our INSAT 3D which was launched, 3DS, and then currently we are also working with France on a program called Trishna, where on a global scale at a very high resolution the SST will be measured, and using these capabilities, how to actually make sure that we can provide better solutions tomorrow is the basic objective here. Krishna itself is a thermal infrared imaging satellite for high resolution natural resource assessment. It can provide almost 1,000 kilometer swath with 57 meter for coastal area and 1 kilometer over open ocean. This again another very important mission which is going to go up later this year. Already the payload is integrated with the satellite, and satellite has gone through all the tests. It is getting ready for launch later this year. It provides a globally information on coast and ocean, cryosphere, then deformation, hydrology, and ecosystem. And all of this enables substantial amount of global data going to be available to the research community. Now, if you look at in the end, currently 2021 to 2030 is the UN Ocean Decade, where ocean observing in support of sustainable blue economy development is the target. Science that we do for the oceans we want is the logo, you can say. And this has been launched in January of 2021 with a mission to catalyze transformative ocean science solutions for sustainable development and connecting people and the ocean. And the major goals are a clean and safe ocean, hazards and marine pollution to be avoided, then healthy and resilient ocean, marine ecosystem understanding, then a predicted ocean. That means you are also in a position to be future ready and then provide solutions to the problems you are likely to encounter. A transparent ocean, then develop a sustainable and equitable ocean economy. In fact, this is also the important aspect. And this conference itself is providing a tremendous opportunity to all the participants to not only exchange their ideas, but also look at what needs to be done in the immediate future, taking advantage of all the development that are happening in various areas of whether it is observation or computational capabilities which are coming up, and using them, and also using the both machine learning, artificial intelligence, and computational systems which are going to provide significantly much better capabilities with the quantum computations coming up. But all of that requires human beings with drive to make use of these tools and adapt them to solve the problems we face today and we are likely to face tomorrow. And that is where events like this, with participation of research community across, is going to make a difference. Let me wish this program a great success. Thank you.
Thank you so much, Professor Kiran Kumar sir, for this very informative as well as exhaustive presentation on the use of Earth observations for the benefit of mankind, especially the sustainable use of oceans and blue economy for the well-being of mankind, and in the with a very clear Indian perspective, the kind of progress we made through the several decades, and where we stand, and how we in future actually not only work for the country but also for the global mankind. So with a new mission on the NISR which is going to come up, I think we are India is standing up to the future of this world. I think that's something especially important to be mentioned. So thank you so much for that very elegant talk, sir. Once again, it was our pleasure then to have have you here. Thank you so much, sir. Now we move on to the next important plenary speaker, Dr. Malini Shankar, the Vice Chancellor of the Indian Maritime University. Uh, she just could just join us now, so I could not give an introduction at the beginning. I would like to introduce her again. Uh, Dr. Malini Shankar is a career bureaucrat belonging to the 1984 batch of the Indian Administrative Service. She had an illustrious career spanning more than 4 decades, with the last assignment as the Director General of Shipping on the rank of a Secretary to the Government of India. Currently, she is the Vice Chancellor of the IMU, that is the Indian Maritime University, also a member of the government appointed board of directors of IL&FS group of companies. But you also must be wondering actually also, because being a science congress, why she is here. Actually, she also has a very strong science background. I just could read that actually she also holds a master's degree in chemistry from Mount Holyoke College in Massachusetts in USA. And I was told that actually she was about to do her PhD. When she came to India, she decided to take to IAS, and then finally she's here with us. But that also helped us actually her to get further doctoral degree on institutional economics from the IIT Madras, and management degrees, of course, from Asian Institute of Management, Manila, Philippines, and so on. So very academic as well as very illustrious, administrative career. And she also had her professional mid-career training in IIT in Paris, France, where she also obtained a diploma in international economics. And a large part of her career also has a connection to the today's conference. That is the water. Water has been her theme most of the time, where we work from starting from municipal to irrigation to environment and economic sectors, including power, commerce, industry, and shipping, ending with in shipping, which tells why she is actually leading the Indian Maritime University, which is also highly relevant to the kind of the audience sitting here. She has been a recipient of several academic recognitions. In fact, in recognition of her professional achievements, she has also been invited by various academic and professional organizations to contribute policy making, and also represented India in many international fora. She was nominated by the IMO as a honorary member of the board of directors of World Maritime University. And even more recently, she has been selected as one of the 7 global recipient of AAA award by the Asian Institute of Management, Manila in Philippines. And she is the first Indian woman to receive that award. So with that, kind of the this one, the big applause to her, and I invite Dr. Shankar to give her, presentation.
Thank you very much, and good morning to all. Dr. Kiran Kumar and all the delegates, the director of NIOT, the director of Vigyan Bharati. I'm very, very happy to be amidst you today, and thank you for having invited me to share my thoughts. It's a very, very difficult proposition to follow somebody like Dr. Kiran Kumar, who gave a very comprehensive technical talk. As the introduction mentioned, my foundation was definitely in pure sciences, and I was doing my PhD in organic chemistry when I decided to come back to India because that's where I wanted to be. And then I found I'm a better fit for the civil service. And since I got in, I never went back. So although the umbilical cord with science was cut off, I don't think you can have science in your background and forget it ever. So I'm back here in the Indian Maritime University and launching initiatives in research in the ocean sciences. We all know, and I don't have to repeat it, that the oceans are vast and they occupy more than three-fourths of the Earth's surface. The resources of the ocean are also vast, and relative to the exploration of land based resources, very little of it has been explored in the oceans. The World Bank, I have no presentation, so this is going to be a test for both you and me to see whether you can, you know, be alert for the next 15 minutes. I will not take very long. The World Bank estimated the global ocean economy to be worth US dollar 1.5 trillion annually. According to the OECD, approximately 40 million people are directly employed in ocean based industries, with millions more employed in related areas. The Food and Agriculture Organization reports that fisheries and aquaculture provide employment to over 59 million people across the world, and it contributes to US dollar 270 billion to the global economy every year. Likewise, the International Maritime Organization, the IMO, estimates that shipping contributes around 575 billion US dollars to the global economy. And the World Travel and Tourism Council states that the ocean based tourism generates over US dollar 1.5 trillion in global revenue annually. The International Renewable Energy Agency, or IRENA, estimates that offshore wind, tidal, and wave energy could meet a substantial portion of the demand of global electricity with a potential to reach about 5,000 gigawatts by the year 2050. The global market for marine biotechnology is projected to reach 8.9 billion US dollars as early as 2026, according to Grand View Research. The focus of the government of India on oceans and ocean-based resources in its intense form is comparatively a recent phenomenon. The Blue Economy Policy draft envisages the sustainable utilization of ocean resources for economic growth, improved livelihoods, and health of the ecosystems. It covers a wide range of economic activities that rely on the ocean and its resources. The components of blue economy include marine protected areas or MPAs, sustainable fisheries and aquaculture, ocean renewable energy, marine tourism, blue biotechnology, waste management and marine pollution control, ocean governance, and international cooperation. The principles of blue economy encompass the attributes of sustainability, conservation, collaboration, innovation, inclusion, and resilience. It emphasizes the importance of striking a balance between economic progress, environmental sustainability, social equity, and cultural preservation. It also encourages the effective and responsible use of marine resources to achieve long term prosperity while protecting at the same time the health and resilience of the ocean systems. A little bit on the evolution of the blue economy, and that's where I wanted a slide, not for the entire presentation. But it hasn't arrived, so I'll have to just you'll have to bear with my talk. The early exploitation era of the oceans in the modern era goes back to 15th to 17th centuries. This era marked the age of exploration as well as exploitation. This period opened up new sea routes and established colonial empires based on the exploitation of overseas territories for resources and wealth. The whaling era, lasted from 17th to the 20th century, and this period witnessed the extensive hunting of whales by UK, USA, Japan, and this led to the thoughts of conservation, which arose in the late 20th century, with worries about overfishing, pollution, habitat degradation, all of which raised awareness of the need for ocean conservation. And you had the emergence of organizations such as Greenpeace and the World Wildlife Fund. In 1992, in the Rio Earth Summit took place, the United Nations Conference on Environment and Development emphasized the need to integrate environmental preservation and economic development. Agenda 21, which was one of the summit's outcomes, called for sustainable management and conservation of the oceans. The early 20th century witnessed a shift towards integrated ocean management, with a growing realization of the connectivity between marine systems and human activities. The phrase blue economy became popular in the first decade of the 2000s, following the publishing of reports by organizations such as the World Bank and the European Union. The United Nations Sustainable Development Goal SDG 14, Life Below Water, is primarily concerned with the conservation and sustainable use of the oceans, seas, and marine resources and calls for international cooperation and governance. In 2016, initiatives and agreements were developed to promote the blue economy and solve ocean related concerns. These include the Port State Measures Agreement, which combats illicit, unreported, and unregulated or IUU fishing, and the Paris Agreement, which addresses climate change. Now, what is the need for ocean research? The oceans are crucial for understanding, protecting, and utilizing the Earth's resources in a sustainable manner. Research on oceans provide knowledge and evidence base that is crucial for informed decision making, policy development, and actions to ensure health, resilience, and prosperity of both the marine ecosystems as well as of coastal communities. Considering the impact of oceans on life and land, studies and research of its varied components is essential for the betterment of living things. Besides the emerging areas of AUVs for explorations, deep sea mining, and ocean remote sensing, the areas of research include a whole spectrum, and I will name a few. I understand that there are students here, so they will probably benefit from this. Firstly, it's climate change because oceans influence the climate patterns, such as climate circulation, temperature variations, and carbon dioxide absorption. Biodiversity conservation to understand the marine ecosystems, biodiversity hotspots, and interdependencies between species, effective conservation, and sustainable management of marine biodiversity. Research and resource management will help us assess the abundance, distribution, and sustainable utilization of resources such as fish, minerals, energy, pharmaceuticals, fisheries management, marine spatial planning, and the development of sustainable ocean industries. Research and pollution monitoring and control will monitor the extent and impact of ocean pollution, identify sources, and develop strategies for mitigation and remediation, which are essential for protecting the marine ecosystems and human health. We need research on disaster management to understand the processes behind calamities such as cyclones, tsunamis, storm surge, etc., and develop early warning systems, improve disaster preparedness and response measures. And this can save millions of lives and minimize economic losses. Research is also required in economic opportunities and development to identify emerging trends, assess market potential, and develop innovative technologies and business models for fisheries, aquaculture, shipping, tourism, renewable energy, deep sea mining, biotechnology, etc., to support the growth of the blue economy while ensuring its sustainability. Trends in oceanic research reveals that the earth sciences and environment in ecology studies account for a lion's share of research on oceans. Marine biology, geology, geochemistry, archaeology, and zoology and animal ecology are other leading domains for studies. Climate change research has gained momentum since 2015, while the research on microplastics has seen a 10 times growth between 2015 and 2020. India's effort to generate pharmaceuticals from the oceans began in November 1990 with 10 laboratories participating, led by the Central Drug Research Institute. Approximately 140 marine creatures were detected to have potential value, and 50 have demonstrated promise in antiviral, anti inflammatory, antifungal, hypotensive, and diuretic properties. India's futuristic ocean research includes oceanography from the space, and I think that was dwelt upon by Dr. Kiran Kumar, deep sea water mission in the form of Samudrayan, renewable energy through tidal power, deep sea mining, and Arctic explorations. Of these, in the next few minutes, I would like to touch upon two frontier areas that are particularly critical for India's geopolitical significance and leadership in ocean studies, and they are deep sea mining and Arctic Ocean. Deep sea mining is a subset of the blue economy that involves the extraction of valuable minerals from the ocean floor, such as polymetallic nodules, sulfides, and ferromanganese crust. These minerals, as we all know, hold potential economic value in the fields of electronics, renewable energy, and infrastructural development. The first successful cruise for polymetallic nodules was undertaken in 1980 by the National Institute of Oceanography in the Indian Ocean, thus becoming the first country in the world to have the registration of a mine site of 150,000 square kilometers. The high seas and the international ocean floor are governed by the UNCLOS, or the United Nations Convention on Law of the Seas. The International Seabed Authority regulates the deep sea mining activities in locations outside the national jurisdiction, and countries manage their own maritime territory as well as the exclusive economic zones. Now, several nations, including India, have set their eyes on deep sea mining, while 18 states, that is, 18 nations, have actually opposed it. Under the treaty, the seabed and its mineral resources are considered the common heritage of mankind that must be managed in a way that protects the interests of humanity through the sharing of economic benefits, support for marine scientific research, and protecting marine environments. At present, the Indian Mining Act, the Environmental Protection Act, and the Coastal Regulations Zone notification constitute the legal framework in India. Regulations need to be developed that are consistent with the obligation of both UNCLOS and the International Seabed Authority. Sustainable exploration of the seabed comes with riders on the consequences of marine ecology. Environmentalists have voiced their concern regarding the adverse impact of deep sea mining on the ocean environment, which is already facing threats from global warming, ocean acidification, pollution, plastic debris, and fishing. A survey conducted in Clarion Clipperton Zone, an area comprising 4.5 million square kilometers in the Pacific Ocean reveal the presence of 154 hitherto unknown bristleworm species. The existence of numerous unknown species, the ecosystems, and the risk of losing such vast, unexplored and unknown knowledge can be a monumental error. It's okay. The Council of the International Seabed Authority is in a tight council could likely face litigation if they favor or block mining activities on the high seas. The International Seabed Authority again finds itself in a sticky situation after Nauru, a tiny island northeast of Australia, invoked the United Nations Convention on the Law of the Sea in June 2021 with a view to deep sea mining. This gave the ISA a 2 year deadline to either develop regulations for deep sea mining or allow mining proposals without international consensus on rules. This deadline is reported to have expired on July 9th, 2023. As Norway becomes the first country to approve deep sea mining, scientists are alarmed, but supporters insist that it will aid in energy transition. We in India need to take a great leap forward, as we did in the telecom sector when we moved from wireless directly into the landline, from the landline development to wireless, rather than trudging through the development of landlines. This great leap needs to be done through targeted research and so that we are prepared when the international regulations of deep sea mining come into force. The second area pertains to Arctic explorations. Besides the impact on climate change and energy resource, the Arctic region holds importance for commercial shipping, opening up new routes such as the North Sea route, Northwest Passage, Transpolar Sea route, and the Arctic Bridge. Technological advancements cover remote sensing, icebreaker vessels, environmental monitoring techniques, and under ice navigation. From signing the Svalbard Treaty in 1920 to the first scientific expedition in 2007 and establishing a research base called Himadri in 2008, India has engaged with the Arctic region. India's Arctic mission also aims at harmonizing polar research with the third pole, namely the Himalayas. India has an observer status in the Arctic Council since 2013 and is envisaged to actively contribute to Arctic policy making. The Indian Maritime University has gained membership in the Arctic University in June 2023 with a view to engaging in scientific cooperation and data sharing. Now, all this comes under the umbrella of ocean governance, which applies to a larger canvas related to ocean resource management and regulation that includes marine biodiversity, fisheries, shipping, pollution, and maritime security. UNCLOS, national legislations, regional cooperation mechanisms, marine spatial planning, marine protected areas, scientific research, and stakeholder engagement are critical components of ocean governance that call for collaboration among governments, industry stakeholders, and coastal communities. 64% of the marine waters are beyond the national jurisdictions, and a total of more than 300 United Nations related agencies are involved in international ocean governance. There is no single overarching body. Territorial disputes, conflicts over navigational rights, resource competition, disputes over responsibility for marine pollution incidents are a few of the challenges in governing the oceans. I believe that ocean studies will be one of the most significant areas for scientific involvement in the near future, if not already. Research and development in the ocean sector involves collection of a host of data, which in turn requires investment in satellites, research vessels, moored buoys, and autonomous vehicles. It is known that scientific institutions in India have the capability. Cooperative ocean knowledge clusters would enable the leveraging of the investment and this capability. In my opinion, we need a two pronged approach. One, which is technical and operational, within the ambit of the National Institute of Ocean Technology and allied scientific organizations. And two, legal and governance and policy issues, which need to intertwine with the technological advancements. From this perspective, it is desirable that ocean science research clusters are catalyzed in order to facilitate an integrated and strategic approach to the vast field of oceanic sciences and propel the efforts towards the achievement of the objectives of blue economy principles and policies. Thank you, and thank you for your patience.
Thank you so much, Dr. Maldi Shankar, for that excellent insight into the early days of ocean, looking ocean as a pure source of resource in terms of living resource, and for that matter, to the days actually wherein actually looking at the ocean, also looking towards more sustainable use of ocean for both living as well as non-living resources, because the ocean being so dynamic nature, it's not only just that it's just not a place for only resources. It also has connection to the world, how the well-being of the planet, as well as the future of the mankind, and so on. She also touched upon the strategic nature of the some of this most important the the looking ocean as a resource, especially for in terms of deep sea mining and other activities, which could have a very profound implication for the future of mankind. And also, more importantly, she touched upon the importance of looking the regions which are that are remote from our places, like polar regions and especially the Arctic, which is becoming the hotbed of the international geopolitics of late. Because as the ocean, the Arctic ice is melting, actually, it's also opening new sea route, potential of new resources, both living and non-living, and the associated conflicts that could be coming into play. So the also she also gave a final overview actually what we should be focusing. How do we use the both the use of the soft power as well as the policy implications, use of our policy to buttress the our the use of the blue economy in a much sustainable way. So thank you so much, ma'am, and I'm also thankful to the both the speakers, despite giving a very little less time than actually which was the originally was supposed to be. So they managed to live up to the very concise presentations as well as lecture, which brings us to the situation where we are quite the right timing, just able to finish the plenary session by 1 o'clock as we promised. And thank you so much for all of you being a patient, listeners, as well as, you know, we hope to have more interactions in the more technical sessions in the afternoon and so on. Thank you so much. Over to the organizers, please.
Thanks a lot, sir. Um, with this, we've come to the end of the first plenary session. I request the chair, Dr. Milot, to present our respected plenary speakers with a terrarium. Please, sir. Dr. A.S. Kiran Kumar. And to Dr. Malini V. Shankar. Thank you, sir. I now request Dr. Shenoy to present a digital clock as a token of gratitude to the chair of this session, Dr. Tamban Melot, Director, NCPOR Goa. Thank you very much. There are some announcements. One, lunch will be at D6, the same location where you might have assembled for tea. And please reassemble at respective session locations by 2 p.m. after lunch. And please, speakers are to submit their presentations at the respective locations or to the respective organizers before their sessions. Thank you very much.